Hello, this is Vignesh from Period 1, and I made the screencast to review Units 1 through 3 for the midterm. Now, Units 1 through 3 were 1D and 2D kinematics / dynamics, and here were some of the key formulas that we learned in these units. The first one was actually over here, which is displacement equals initial position plus velocity times time. Then next we learned velocity equals initial velocity plus acceleration times time. Then using these two formulas, we derived these two over here. This one does not need time, and you can find velocity using acceleration and displacement. And this one uses displacement, and you can find the displacement using acceleration and time. And this one over here was used when we were studying forces, and it was Newton's second law, which is acceleration equals the sum of forces over mass. Now, to review these two units, I used some practice problems from before and solved them. So here's the first one. It involves pulleys and inclined planes. My first step was to write down all the forces. So for the 4 kilogram block, which is over here, the force would be mg sine theta. For the 2 kilogram block, which is over here, it would just be mg, since it's not on an incline. The 10 kilogram block, which is over here, does not have any forces acting on it, since there's no friction. And finally, the 8 kilogram block, which is over here, would be mg sine theta, just as this was, except the mass and the angle are different. So for the direction of these forces, I made right positive and left negative. Now if you look at the diagram again, the 4 kilogram block is the only one that's pushing to the left, while the 2 kilogram and the 8 kilogram block are pushing to the right, as I stated over here. Now, my next step was to write down the equation for the sum of the forces. So the 8 kilogram and the 2 kilogram block would be the positive over here, and the 4 kilogram block would be the negative over here. Then, once you plug in the values and put it into the full equation, which was Newton's second law, which is acceleration equals sum of forces over mass, you get the following acceleration. So over here, again, is the 8 kilogram block, over here, the 2 kilogram block, and over here is the 4 kilogram block. Now, notice how I put the 10 kilogram block here, even though there's no forces acting on it. And that's because we still have to include this mass because it's in our system. So the final answer for this problem would be 1.6 meters per second squared, if you plug in all your values. Now, problem 2 was another problem which involved 2D kinematics, and this problem uses projectile motion. In this case, the projectile was an actual human. So, on May 20th, 1999, Robbie Knievel easily cleared a narrow part of the Grand Canyon during a world record distance motorcycle jump, 228 meters. Now this was initially feet, but I changed it to meters because I do not feel like converting units. He left the ramp at a 10 degree angle above the horizontal. So how fast was he traveling when he left the ramp? Okay. So first, it's best to start out projectile motion problems with a sketch. So if you imagine Robbie Knievel is over here on his motorcycle, and he's going at v meters per second over here across a distance of 228 meters. Probably should write the units. Now, my second step after drawing the sketch was writing all the physical quantities that we know. So the range, which is just x, would be 228 meters. The velocity, which we do not know, we can just assign as the variable v. Horizontal velocity would be v cosine theta, and vertical velocity would be v sine theta. And we also know the vertical acceleration to be negative 9.8 meters per second squared. and theta is 10 degrees. So here are the equations. Now we can let t equal half the time of the jump, and this is useful because if we let t equal half of the jump, then it would be at its max height, where velocity would be 0. So for the horizontal equation, we can use vt cosine theta would give us 228 over 2. So it's the range over 2, which is half the distance, and horizontal velocity times time, which would give us displacement. And displacement's over here. So then once you solve for t, you get 114 over v cosine theta. Then for the vertical component, you have, I would use the equation v equals v sub o plus at. So v is 0, we know that. V sub o, which we're solving for, is v sine theta, as I said before, and our acceleration is negative 9.8, and t is again what we're solving for. So over here, once you solve for t, you get v sine theta over 9.8. So now you have two values for t, one over here and one over here. So what we do next is bring it all together. We let those two values equal each other. So 114 over v cosine theta equals v sine theta over 9.8. So right now it's just a proportion. So you cross multiply and get v squared times sine theta times cosine theta equals 114 times 9.8. So v squared equals 6,532.95, and once you take the square root of that, you get 81 meters per second. Now this is not realistic because 81 meters per second would be impossible on a motorcycle, at least using the technology we have today. But anyways, that's how you solve projectile motion problem. So step 1, take a sketch. Step 2, write your physical quantities that you know about. And step 3, solve for all the variables you don't know. So some assumptions that we had to make for this was that air resistance would of course have to be negligible, and he would also have to land at the same height that he was before. Thank you for listening to this screencast. I hope you learned a lot.